Now that you have your nodes communicating, it's time to verify that you can send messages back and forth. So begin with your switch node, in my case the one on the left, and start on the console, and you can either type directly into the large console window area or the small text box at the bottom of the console. If you use the small window at the bottom, you'll have some scroll back history and you'll be able to edit the commands before they're inputted into the console input. So we're going to enter the first command, which is ZCL on-off toggle, and that's going to construct a ZigBee cluster library on-off clusters toggle command frame. And you'll get some output that confirms that that's built, and it says cluster ID 6, the on-off cluster, command ID 2, the toggle message, and length 3. So those 3 bytes are 1 for the frame control, 0 for the ZCL sequence number, and 2 for the command ID that corresponds to toggle. Now you're going to want to send that to the light, and in this case we made sure that we configured our light as the coordinator. The coordinator happens to always in a ZigBee network have a node ID of 0000. Normally ZigBee nodes have a random node ID, but in the case of the coordinator, it always has a fixed address, which makes this example much easier because we don't have to guess what random ID has been assigned to the joining node. The switch has a random ID, but as the light has a fixed address of 0, we're going to be able to type send and the address of the coordinator, which is 0, and the source endpoint of the message, which is endpoint 1, the client endpoint on the switch node, where the on-off switch was configured, and then the destination endpoint on the target node where the on-off toggle message should go. In this case, there's only one endpoint defined on the light, so we know that it's endpoint 1. But in the real world, since any endpoint can be chosen, the switch would have to use some kind of endpoint discovery mechanism to learn what kind of endpoints are available on the remote node and which one is appropriate to receive this on-off toggle message. So after entering the message, we can press enter, and you should see a note that says that the on-off command got received on the light node and that the value was toggled, and then a response message should be generated. So you'll see a note on the switch that indicates that something was received. This received message indicates a default response from the ZigBee cluster library. This indicates that the message was processed by the ZCL on the light. It's a bit like a ZCL layer acknowledgement. So let's look into the traffic. I'll go ahead and stop the capture so that we can prevent new traffic from coming in while we're trying to examine what's been captured. And now let's go ahead and maximize the captured area so that we can have a closer look. This shows the transactions between the two nodes, and the ones in blue are the ZCL transactions that we're interested in. You can see a ZCL toggle message and a ZCL default response message. Now, if you're not sure why there's a transactions view and an events view, we encourage you to watch the Ember desktop getting started videos that introduce some of the features of this tool. So now you'll click on the toggle transaction and see that there's an arrow going from TRN3A2, my switch in my case, to the coordinator, which is the light. You can even change the icon to a light bulb if that helps you remember which is which. And as the light acknowledges that message, you see a default response going back the other way saying, yes, I got your message and I processed it. And if you click on that default response and you go into the event detail pane, you can scroll all the way down to the ZigBee cluster library section of the message decoding, and you can see under the ZigBee cluster library area, you can find in the details that it is a default response for a toggle command, and its status was success, indicating that it was properly processed by the light application. Now, as per step 4 of these sets of instructions, you can confirm that that toggle message actually had the desired effect by printing the attribute table. You can do that by going to the light console and typing print attr, or print a if you like, and that's going to show the list of all the attributes and their data values. So you'll see the number 1 next to on-off, and that indicates on. And if you were to go into your scroll back history on the switch and recall your ZCL on-off toggle command to rebuild it, and then type send 011 again to send it again, you should notice that the toggle command has the intended effect, and you can print the attribute table to confirm that the attribute's value has changed from a 1 back to a 0. So we've successfully got the devices communicating back and forth and the attribute toggling in software. So now it's time to change what happens when those toggle messages are received so that it starts changing the activity of the LED based on the attribute data on the light. And then we'll change the switch code so that the switch can react to a button press instead of us having to feed it CLI commands.